Okay, hello students. We are going to be looking at roof cladding today. So I want you to be able to identify different types of roofs, in particular the gable, the box gable and the hip height roof. And then we're going to be able to calculate the number of tiles on a roof and the length of colour bond needed to clad as a gable, a box gable or a hip roof. So if we want to classify our different sorts of roofs, we can see first of all our gable roof is just made up of two rectangles. So we've got one rectangle here and one on the other side, so number 1 and number 2. If I have a look at a box gable roof, it will have an extra 2 triangles on here, so it will have another triangle here and one on the other side. So that would then correlate to this part here. And then if I have a look at a hip roof, you'll notice that it is a trapezium and another trapezium and then 2 triangles. So let's have a look there. So we've got our first trapezium, and so that could relate to that one, and then there's the second one that would relate to that, and then we would see a triangle there, so that's our triangle, and the third one, the fourth side would be another triangle. So we also have some different sorts of cladding. So cladding is what we cover a roof with. So we'll talk about tiles and colour bond. Now tiles are generally going to be a little bit cheaper but more labour intensive, and they'll need a stronger frame. Now that roof frame we learned was a truss, and it's going to need more structural supports because the tiles are tied to the roof, and therefore it's going to be more labour intensive. To calculate the number of tiles, we're just going to say the area of the roof divided by the area of each tile and multiply by the cost of the tiles per square metre. Now colour bond is what we think of as corrugated iron roof. So that's the corrugations there are just to help the drainage and to add strength. Now colour bond is wider than 762 millimetres, but when they overlap, that's effectively the width of the colour bond that you're going to be able to use. So then we'll just line up all those lengths on the roof and get a total length of a colour bond. But we'll get to that in a minute. So the number of sheets of colour bond that we're going to use is just going to be the width of the roof divided by the effective width of the colour bond. So let's have a look at a gable roof problem. So we've got a 20 by 15 metre building with a gable roof. It's got a pitch of 15 degrees and it's going to be cladded with colour bond. How many metres of colour bond are required? So what we're going to do is just go through the problem solving steps. So remember, we want to be able to look at the knowns, to draw the diagram and fill in the information. Then we're going to work out the unknown. What is the question actually asking for? We're going to make a strategy, solve it, and then reflect. Does this actually make sense? So first of all, we've got the bottom of the house, and let's draw in what we know. We know that we've got a roof. We know it's a gable roof, so we're just looking at the 2 rectangles. We know that the side of the house is 15 and the length of the house is 20 metres. But we don't really know then how long that is. We know that from there to there is 7.5, and from there to there is 7.5, but we've got a hypotenuse here to work out. So we're going to have to work out this with a little bit of trigonometry. So here's our hypotenuse along here, and we know that we've got 7.5 metres along here because that's half of 15. So we just use a little bit of trig, and so with the roof, the roof height, or the length of this roof along here, is going to be needed to work out with SOHCAHTOA. So that's our hypotenuse. Let's use a yellow now. That's our hypotenuse, that's our opposite, that's our adjacent. So We don't care about the opposite, so that rules out sine. We do know the angle, so we know the adjacent, and we want to find the hypotenuse. So it's got to be cos, and can't use tan because we don't really care about the opposite. So we know that the cosine of any angle is the adjacent divided by the hypotenuse. So we'll rearrange that to find the hypotenuse. So the hypotenuse is just adjacent divided by the cosine of the angle. So we'll substitute that in now and say the adjacent is 7.5. We know that the cosine and the angle is cosine 15. So we just say 7.5 divided by cosine 15 will give us 7.76 meters. So there is the length of our roof, 7.76 meters. Now we just need to do is to consider how many widths of colour bond can we fit across the top of the roof. And so that's the number of sheets. And so from here to here is going to be 762 millimeters for each one of those. So we just say the width of the roof, well, that's 20 meters divided by the effective width of the colour bond. Well, that's 762 millimeters. We do need to do the unit conversion to make them all into a common unit. So put them both into meters, and that will give us 26.42 sheets per side. Now, that means it's going to be rounded up to 27 sheets per side, and we've got two sides. So that's 27 times 2, that's 54. And then we're going to say, well, we need 54 sheets that are 7.76 meters, which is really 419.4 meters in colour bond that are required. So we've solved our problem, and then that answer makes sense. We've got it in a linear meter unit, and the number looks a bit right. It looks right. Now, a hip roof is a little bit more difficult to consider. So remember I said that we've got a triangle there, a triangle on the other side, and we have these two trapeziums. So first of all, I want to think about the squares here. So if I have a look here, this shape is a square. So from here to here, that we have an angle of 45 degrees. So the half of the width of the roof. So for example, if this was 10 meters here and this was 20 meters here, that means we've got 5 meters there. That would mean we've got 5 there, 5 there, 5 there, and 5 there. So we have these little squares here, and they're coming in at a 45-degree angle. That's what you can see here. Half of 90 is 45. So if we were to think about then the length of the top up here, that would have to be 20. Take 5 on this side because we've come in 5. Take off 5 on this side. And so that would be 10. So that's 10 meters up there. So that's a bit of a tricky one to think about. So remember that we said that it was 20 down there, and that would make that 10 up there. So that would make this 20 down here and 10 up here. If that's 5, that's 5, and so on. So that's a hip roof. So be careful to work that out when you do your calculations. Okay, let's now consider tiling a hip roof. So we've got the building with the same dimensions as before. It's 20 by 15, and the pitch is the same as before. So let's consider now how many square meters of tiles are required. So we need to draw a diagram just to help us get our head around it. So we've got a hip roof, and we'll put in some extra detail, and we'll put in the internal measurement. So remember, it comes in as a square because these are coming in at 45 degrees. So that means we're coming in 7.5 meters that side and 7.5 meters that side. That makes 15 meters. So the top of the ridge must be the bottom of the ridge, the bottom minus that 15. So the top of the ridge is going to be 5 meters. Now let's work out the length of the roof. So remember, as before, we want to find that there. It's not going to be 7.5 because 7.5 is halfway along the bottom. We're looking at the hypotenuse. So we need to consider the pitch of the roof, and we know that the adjacent is 7.5 there. So that's that one there. And we know that the pitch is 15. So we can do the calculation with trigonometry again, and it's just going to be the same one as we did before. And so we know that the cosine of the angle equals the adjacent over the hypotenuse. We can see the adjacent, which is 7.5. We can see the angle, which is 15. We need to find out the hypotenuse. So we just need to rearrange that to say the hypotenuse equals the adjacent divided by the cosine of the angle, which is 7.5 divided by cos 15. And that should give us 7.76 meters. So we know that the height of the trapezium there on that side of the house is 7.76. Now, because they also come in at 45 degrees, the height of that triangle will also be 7.76 meters. So let's draw the triangles and the trapezia in. And we have two triangles and we have two trapezia. We've calculated their dimensions, and it's important that you communicate these diagrams to me so I know that you're talking correctly, so we can transfer the information from a fairly complex roof diagram into some simpler diagrams here to calculate the area. So we can look at the height of the triangle is 7.76. The base of the triangle is 15 meters. If we have a look at the trapezia, the height of the trapezium is 7.76. The top of the ridge of the roof was 5, and the bottom of the roof was 20 meters. So let's do the calculations now. So we know that the area of a triangle equals the base times height over 2, which is the base of 15 multiplied by the height of 7.76 divided by 2 is 58.2 meters squared. Now, if we have a look at the area of the trapezium, it's the average of these two sides. So add those two together and divide them. So 20 plus 5 is 25. So it's really 12.5. And then you just treat it like a rectangle. So it's 12.5 multiplied by 7.76. And that's going to be 97 square meters. Now remember, we've got two triangles and two trapezia. So we'll add the two trapezia together, and then we'll add the two triangles together, and that will give us a total of 310 square meters. Finally, your exercise is exercise 7H, and that's on page 282.